Right now, we're going to go over vector notations and also how to resolve a vector because you're going to need this when you learn physics. So let's say we have a vector A, and if the vector is expressed in unit vector notation, then we will write something like this. So we have vector A that has the x component and the y component. So you have a sub x, that's in the horizontal x-axis, and then you have the a sub y, which is in the vertical j direction. So you have I hat and j hat. And you have the x component and the y component. So let's say you have a vector that's like this, that's pointing in the first quadrant. So this is your vector A. And the magnitude of vector A. So I will just drop the arrow, the overhead arrows. Just said that A, the magnitude of the vector A is 5, and the angle that's making with the horizontal positive x-axis. This is your theta, and your theta is 30 degrees. So that's it. You have a vector that's pointing in the first quadrant with the magnitude and directions given. Now, how do you find the x and y components? So if the angle is measured from the positive x-axis, you can always use this formula to calculate the horizontal component and the vertical component. So I'm just going to write down that A, vector A, the horizontal component will be just the magnitude of A, and then times cosine, the angle that is making with the positive x-axis. So in this case, you have A and then cosine theta, I hat, and then plus A sine theta, j hat. So in this case, when you plug in all the numerical numbers, you have 5 times cosine 30 degrees I hat plus 5 times sine theta degree j hat. You should get 4.33. That's in the horizontal direction, I hat, and then plus 2.5 j hat. That's in the vertical direction. Okay, so this is when you have a vector that's pointing in the first quadrant. What about when you have a vector that's pointing in the second quadrant? So let's say another situation that you have the same magnitude of A, and so this is your vector A, and now the angle is not defined from the positive x-axis, it's actually defined from the positive y-axis. So in this case, how would you resolve the vectors? So what you need to do is that recognizing that this theta is a smaller angle. So draw a dashed line that's proportional, that is actually parallel to the horizontal x-axis, and then your s component. So this is your vector A. Your s component is still equal to the magnitude of A, and then times, because if you look at the horizontal component, which is this one is opposite the angle. So instead of using cosine theta, what you should do is use sine theta. Okay, so you have A and then times sine theta, and then I hat plus A times cosine theta, because that's adjacent to the angle, that's a vertical component, j hat. So in this case, you plug in the number, so you have your 5 times sine 30 degrees, I hat, and then plus 5 times cosine 30 degree j hat. Now the other thing you have to pay attention to is that because you're using the smaller angle, so in other words, the angle is not defined from the positive x-axis, it is actually the smaller angle, less than 90 degrees. So when you use a smaller angle definition, then you have to manually insert negative sign if the vector is pointing in, not in the first quadrant. So in this case, the vector A is pointing in this direction, which means that it has a negative x component and a positive y component. So in this case, I forgot to put a negative sign in front of it. So there's a negative sign here, negative sign there in the horizontal direction. So in this case, you have negative a times sine theta I hat plus a times cosine theta j hat. So numerically, you should get negative 2.5 I hats and then plus 4.33 j hat. So you can see that really depends on the angle that is given. You would use the you would not always use the x component as a times cosine theta and the y component as a sine theta, because it really depends on which angle you're given. So this is when you have a vector that's pointing in the second quadrant. What about when you have a vector that's pointing in the third quadrant? Let's say you have a vector that is pointing in this direction. Okay, same magnitude, but now the angle that say is defined as this one. So you can see that this vector is pointing in the third quadrant, which means that it has a negative x component and a negative y component. So again, we're going to use a smaller angle definition. So if you use a smaller angle definition, so draw a dashed line here, and then you can see that your vector A is equal to the x component. So what is your x component? The x component is this one, which is adjacent to the angle. So you will use cosine. Okay, so you have a times cosine theta I hat. Again, when you're using smaller angle, you have to manually insert a negative sign. So in this case, you have a negative x component. Likewise, for the y component, it is also negative. So you use minus a and then sine theta j hats. So when you plug in the numbers, so a is 5 and theta is 30 degrees, then you will get negative 4.33 I hats, and then minus 2.5 j hat. So a lot of students want us, what about the sine and cosine if you want to use the angle by convention? So what you can do is that if your angle is measuring from the positive x-axis, then you can use this x component as a cosine, and you can use the y component as sine, and then you don't have to worry about adding manually the signs of the signs. So, for example, now this theta prime, it is measuring from the positive x-axis. That's equal to 90 degrees plus your theta. So theta is 30 degrees. So you'll get 100. You'll get sorry, not 90 degrees, 180 degrees. So you have 180 degrees plus 30 degrees. So that will give you 210 degrees. That's measuring from the positive x-axis. So use that angle. If you want to use the angle that's measuring from the positive x-axis, then you can safely just say that your vector A is equal to A times cosine 210 I hats, and then plus A times sine 210 j hats. So you can see that when I do this one, when I use the angle that's defined from the positive x-axis, I don't have to manually put a negative sign in front of it, because by the conventional definition, the signs will be taken care of when you plug in the numerical numbers. So you will still get negative 4.33 when you punch into the calculators, and then minus 2.5 j hats. Okay, so what about when you have a vector that's pointing in the fourth quadrant? That's in the fourth quadrant. That say you still have the same vector magnitude, and the angle now here is the theta. So you can say that your A. So again, draw a dashed line here as a reference. So your vector A now is equal to the magnitude A, and then times Now the x component is this one, so that's adjacent to the angle. So use cosine theta r hat. So you can see that I'm actually using a smaller angle. Okay, and so the x component is the positive. Now y component is negative, so we have to manually put a negative sign in front of it. So minus a, and then times sine theta j hats. So you plug in a number, you will get 5 times cosine 30 degrees r hat minus 5 times sine 30 degrees j hat. So you will get 4.33 I hats and then minus 2.5 j hats. Okay, so that's that. And so this is how you resolve a vector. This is when you're given the magnitude and the angle, how you resolve the vector. Let's say if you already know the vector, if let's say your vector, this is the vector b, and that's pointing in this quadrant. So this is your vector b, and your vector b is in this magnitude, expressed in unit vector notation. You have, because the x component is negative, so we know that you have a negative, let's say negative 2 I hats, and the positive y component, so plus 3 j hats. Okay, so once you have your vector b like that, how would you find the magnitude of vector b? Then we use the Pythagorean theorem, so your b, the magnitude b, is simply just equal to the x component square and then plus the y component square. And you take the square root of the sum. So you should get your b with a magnitude of 3.6. What about angle? All right, so for angle, really, whenever you're given a vector, you have to draw it on the xy axis and then define your angle. Let's say you define your angle theta here. This is your angle theta. So how would you find this angle? So you draw a dashed line here, okay, and then tangent theta. So just by looking at this triangle, you know that tangent theta is equal to the y component, the opposite, because tangent is defined as sine over cosine. So what is your sine? Your sine here, the sine is opposite the angle, which is the x component. So use the x component, put it in the numerator, and then use the positive value because we're now using the smaller angle. And then your and then the cosine is adjacent, which is the y component. So use 3. So when you do this, you'll find that your theta is equal to 33.69 degrees. Okay, so if you want to express that in by conventional angle definition, then you add 90 degrees to that. So if you add 90 degrees to that, that will be the angle that is measuring from the positive x-axis. Okay, so whenever you do this kind of problem, you just have to and I'll give you 123. You really have to draw the vector in the xy axis and then see which quadrant is pointing to it, and then define your angle theta, and then use a tangent. So tangent is always the sine over cosine. So just by looking at the right triangle, and then decide which component that is sine theta, which component is the cosine theta. Say for this example, your tangent theta, the sine component, the sine will be the x component, and the cosine component, which is adjacent to the angle, is the y component. Okay. Now, if you want to define your angle theta prime here, let's say you divide your angle theta prime here, then again you draw dashed lines as a reference. So your tangent theta prime. So now you're working with the different right triangles. So tangent theta prime is equal to, so sine theta, your sine theta prime is the y component, so you put the y component here. And the cosine is the horizontal component, so you use -2 and then take the absolute value because we're using the smaller angle. So in this case, your theta prime is equal to 56.3 degrees. So in this case, you can see that if you want to measure, if you want to express this, if you want to express the vector using the angle measuring from the positive x-axis, what you should do is that use 100 degrees. So the actual angle is 100 degrees minus 56.3, and that gives you 123.69. And that's consistent with what the previous one, because this is the angle measuring from the positive x-axis, and the 33.69 is measuring from the positive y-axis, and then 56.3 is measuring from the negative x-axis. Okay, so basically these are the essential this is just a refresher about vectors.